In the last session, we discussed the history and evolution of Java, right? Now, let us see the two important features of a Java language called security and portability. Security, right? Java is to be internet programmers language we have discussed, right? Professional programmers language, then a pure object oriented programming language, right? Above all, it's clearly a high level programming language, right? Another important point of Java is Java is said to be a secured programming language, right? We can ask, right, how Java is said to be a secured programming language, right? Security. When we work with internet applications, for example, we can download the corresponding applets, right? And we can execute the corresponding applet. When we download and execute the applet, right? What will happen means the Java runtime environment, right? Java runtime environment comes up with a facility called firewall. When we download the applet, right, and execute the applet, right, the Java runtime environments, right, firewall facility will not allow, right, any other programs, right, or to access, right, the corresponding environment, runtime environment, right. So simply saying that, right, the applet programs, right, will not be affected by, right, or will not be accessed by, right, any other, right, unauthorized access, right. So no malicious effect, right, will affect in the corresponding applet programming because of the runtime environment, right, comes up with a clear, right, firewall facility, right. Outside entries are not allowed, right, into accessing the runtime environment, right. So that's what, right, applets are, right, completely safe, right. So no viral, right, virus infections are possible, right, in the case of an applet programming, right. So Java is said to be, right, the internet programming language. So because of these reasons, right, firewall facility of Java, right, Java is said to be a completely a secured programming language. Another important feature of Java is this one, right, portability, right. You would have seen, right, different high level programming languages, right, C, C++, right, basic, Fortran, right, COBOL. These are some of the high level programming languages. Those are not said to be a portable programming language, right. So portability, right, in the sense that, right, uh, the code can easily be, right, ported from, right, one environment, right, into another one, right. That is the portability feature. To discuss, right, what actually the portability feature, right, or how Java is to be a portable one, right. You consider a C or the C++ application. Suppose consider a file, right, test.c, right. Right, I create one file, right, for example, a test.c here. Creating a file, for example, a test.c, check, right, in version, right, turbo c, let me use. I am writing a file, for example, file new, file new, okay. I am creating one a C program, right, for example, hash include stdio.h and writing a main function, printf. I am writing a query, printf slash n, for example, hi friends, welcome to learn Java. Closing this right main function. Let me save the file, right? The file saves. For example, I am saving the file in a colon tc win45 bin file is, for example, test 123 a colon tc win45 bin. Now let us check the file here. A colon tc win45 bin, refresh. The file is saved, right? Test 123, right? The file is SCPP file, right? So once we created a file, the file is available here. Now the thing is, right? I am pressing F9. What is F9? Compilation, right? Now the compilation is over, right? No compile time errors are reported, right? Now let us check inside the folder bin, right? What happened? Two more files are created, right? One is right the 3D object file, right? After running, right, even you can find right the corresponding backup file, right? Backup file will be produced, and another one is the application file, right? This is said to be the executable file. Now let us check, right? Clicking this executable file test123, what happens? Understand? Clicking the file test123, what happens? The code gets executed. So clearly test123, this is the executable file or the application file, right? So source program is compiled, right? And the corresponding executable file, right? Here you can see test123.exe, right? So this is the executable file. So the outcome is showing here, right? Hi friends, welcome to learn Java, right? Even right, if you run a program right here, for example, I am pressing Control F9, right? Hi friends, welcome to learn Java, right? Now in the folder bin, right, you can check that the files are produced, right? Test123, right? Application file, right? CPP file before that, right? After that, right? Test123 as the 3D object file, right? Backup file, right? Will also right get produced. So in this case, right, after the compilation, you need to understand that, right, once if you compile, right, a C or C++ program, right, so compilation of the C or C++ program, which results in, right, the executable file, compiling and running, right, the file, right, test.c, right, or simply like compiling a file, we will get an executable file. Where in case of Java, right, if you compile a Java program, compiling a Java program, for example, test.java, right, you will not get an executable file. No executable file, no executable file is produced during the compilation. This is important point. So what actually produced, right, using during the compilation means the file test.java, right, is applied to the Java compiler, Java C, right? This is the name of the Java compiler, right? So to compile a Java file, you need to use the Java compiler, right? The syntax is Java C file name dot Java, right? Later, right, we demonstrate, right, how to compile and run the Java code. So compiling the Java file, say file name dot Java using a Java compiler Java C, right? You will be getting a file called a bytecode file. What file is produced? A bytecode file is produced, right? So this is the output of a Java compiler. Java compiler produces a bytecode file, right? That is very important. So what is a bytecode file means? Bytecode files are, right, the highly optimized set of instructions that are executed by the Java runtime environment, right? That is a magic of Java. right? So because of that, right, Java is right essential for right a portability operation, right? Now see here, the output of a Java compiler is a bytecode file, right? So take a note on right what is a bytecode. Bytecode is nothing but a highly optimized set of instructions. Highly optimized set of instructions which are executed by the executed by the Java runtime environment. A highly optimized set of instructions which are executed by the Java runtime environment. That is JRE. JRE is the Java runtime environment, right? That instructions, right? Optimized set of instructions are said to be a bytecode file. Bytecode files, right? Will have an extension class that is dot class. So the compilation of file, right? Test.java, right? You will be getting test.java is applied to the Java compiler. Java C test.java will not produce a bytecode, sorry, will not produce the executable file. Instead, the bytecode file will be produced, right? So the bytecode file will have an extension dot class, test.class, right? We can see, right, what is actually there in a test.class file, but you cannot interpret it, right? You cannot recognize anything from the test.class, right? A bytecode file. For example, see here, I show you, right, some bytecode files produced. Bytecode files are right having the extension right dot class Java. See here, right? These are some of the Java files. Say array typecon.java, this ex.java, superref.java, supereg.java, right? And these are the corresponding bytecode files. Say typecon, triangle, this x, this e, SAPREP, super ergo example, static example, right? These are the bytecode files. For example, if I open one bytecode file, typecon, this is the file, typecon. You cannot recognize anything from, right? Can you recognize, right, what is given in this instruction? Or what is the meaning of this instruction? No, right? So this is the bytecode file, right? The content of the bytecode files are not readable, not recognizable by the user, right? But the bytecode files are only executed by the Java's runtime environment, right? So to have the Java's runtime environment, right, we need what is called JVM. JVM is nothing but Java Virtual Machine. Java Virtual Machine, right, consists of the corresponding runtime environment, right, which is said to be a Java interpreter. Java interpreter, right, interprets the bytecode file. The Java interpreter interprets the bytecode file. So when test.class is given as input to the Java interpreter Java, right? So there you need to use right Java file name Java test. Java C file name Java. This is a syntax to compile a Java program, right? Once a bytecode file is produced, right, you can run the file right using the syntax right Java test, right? Then assuming that right the test right a class right consists of a main method, right? Then the main method right will run using Java's interpreter called Java. Java test, right? So assuming that right here, test.java consists of a main method, right? So Java test means, right, what will happen means, right, your program, right, runs and produces the output, right? So you will be getting the executable code or executable file, right? So in this case, right, you will be getting the required output. So this is the bytecode magic of Java, right? The important fact is, right, when a original source code file is compiled, you will be getting a bytecode file. Bytecode files are running under the Java runtime environment. There, the Java virtual machine, right, should be installed, right? A runtime environment is installed, right? So Java virtual machine, right, consists of a Java interpreter. The Java interpreter interprets the bytecode file so that executable file is produced. So this is compared with, right, the C and C++ languages, say test.c. Test.c, right, compilation which results in the executable file. Where in Java, test.java, right, no executable file is produced during the compilation. Instead, bytecode file is produced. Then the bytecode file is interpreted by the interpreter to have the corresponding executable file, right? So the important concept is here, assuming that, right, you are using, suppose, a Windows 95 operating system. In Windows 95 operating system, assuming that the file test.java has been returned and the file is compiled, right, using Java compiler, having the file test.class is produced, right? Now we can run the file test.class in different operating systems. This is very important. Different platforms or operating systems. Different platforms or operating systems where the Java runtime environment, right? JVM, Java Virtual Machine, should be installed. JVM is installed. So, in for example, in my laptop, right? Assuming that, right, 95 operating system is there, I have a Java compiler. I have written a file test.java. After the compilation, right, the file produced is test.class, right? Next, consider, right, your laptop, right? Assuming that, right, yours is, right, for example, Windows, right, 95 or 98 or Windows, right, 2000, right, or Windows, right, HP or Windows 7 or Windows 10 operating systems, right? So assuming yours is, right, any one of these operating systems, say Windows 10 operating system, right? So in Windows 10 operating system, we are trying to run the original file test.java without having the actual file test.java, but only having the outcome of bytecode file, right? That is the outcome of the compilation file test.class. So when test.class is being compiled in your Windows 10 operating system, assuming that in your Windows 10 operating system, the runtime environment, JRE, Java runtime environment, is installed. You have the interpreter called Java. So using Java test writer, you will get the corresponding output file. Hope you understand the meaning of platform independent, right? So cross platform, right, in different platforms, in different operating systems, right? The bytecode file is easily ported, right? So understand that in your machine, right, we are running the file only test.class. We are not running the actual source code file test.java. So having only the executable file test.class, right? We are running the program indirectly said to be, right, test.java, right? So that we will have the actual output of test.java, right? So because of this feature, right, the bytecode files, right, are easily portable in different operating systems, right? So that the required output is achieved, right, with the help of Java interpreter, Java, right? So that's what Java is said to be, right? Interpreter language. Java is said to be the interpreter language. So Java is said to be a platform independent language. How Java is said to be an interpreted or platform independent language, right? Because of the magic of bytecode, a highly optimized set of instructions, right, which are executed by the Java runtime environment, right, the Java interpreter. Because of this feature, right, Java is said to be, right, architecture neutral language. Architecture neutral. There is no architecture, right, because of its platform independence property. Understand or not? So Java, right, supports for two important features, right? One is the security feature, right, and another one is the portability feature. Because of these reasons, right, Java is said to be a platform independent language. So we are discussing, right, the main features of Java language, right? Java is used for internet applications, right? Applets are, right, mainly used, right, in internet applications, right? The first feature of Java is security. Java is a secured programming language. Java programs, right, applets, right, will not be affected by some viral infections, right? Because of Java runtime environment, right, comes up with clear, right, firewall facility. Second one, Java is said to be a portable language because, right, the output of a Java compiler is not an executable file. Instead, the output of Java compiler is the bytecode file. Bytecode file, right, will run in different operating systems where we need to install the corresponding virtual machine called Java Virtual Machine (JVM). Right, Java Virtual Machine, right, comes up with, right, the security feature, right? So this prevents the generation of some other malicious effect, right, into the corresponding environmental code, right? So outside of the system, right, no outside disturbances, right, will be possible to enter into the corresponding runtime environment. Java is also said to be a interpreter language because of the bytecode magic. Another important compiler for JVM is JIT compiler, right? JIT, which stands for Just in Time Compiler. JIT, right, which stands for Just in Time Compiler. Just in Time Compiler, right? JIT is a part of Java's runtime environment. Say JVM, Just in Time Compiler, compiles the code only, right, just in time compiler, right, compiles the code that is only necessary for the execution, right? Suppose we have different classes, right, a number of classes, right? If you want to execute some particular classes only, right? So because of the structure of the code, right, JIT compiler determines that what are the actual portions of the code, right, which are going to be compiled, right? So that should be determined by the just-in-time compiler, right? So more about just-in-time compiler, right? I will explore, right, in compile time polymorphism, right? So the two important basic features of Java languages are, right, one is security, right? Another one is portability. Java is a secured programming language. Second one, Java is a portable programming language. Still, we need to discuss, right, some other important features of a Java language, right? In the next session, right, we focus on, right, what are servlets, right, and what are other salient, right, special features of Java language and the evolution of Java language, right? And then, right, we will enter into the fundamentals in object-oriented programming, right? And then, right, we discuss, right, the data types, right, constants, variables, right, operators, expressions, control statements, then the general structure of a Java program, right? So that is the focus.